Hello, Planeteers. All right, I have a question for you. How many of you have curled up in front of a fire to read a nice long scientific paper? Yeah, right. I guessed probably not many of you. And how many of you have sat down to, you know, enjoy a sunset while reading a long report from a government agency? Yep. Yeah, I guess probably about the same number of people, right? Zero, maybe one. So, on the other hand, we really want our stories here at the Planet to be read by people who are looking to be educated but also entertained and intrigued, right? If we wrote things at with the sort of engagement of a scientific paper or a bureaucratic report, we would count on not having very many readers, and we don't want that. If you've written your story but no one's going to read it, then it's kind of like a tree falling in the woods with nobody around to hear it. So that's one of the main challenges of writing about environmental issues, is that you are going to be tackling complex things that can be written about in boring ways, right? You're going to be writing about scientific discoveries and scientific research. You're going to be writing about government policies or law, right? And so the unfortunate thing is that these kinds of subjects are often written about in this very sort of dry, technical, jargony way, but really it misses a lot of what's going on with these things. I mean, science is this remarkable enterprise that's being pursued by thousands of people who are really on this kind of heroic quest to try to understand how the world works, right? That sounds amazing. And the same thing is true about government policies. I mean, here you have people who are collectively trying to figure out how to manage the community's affairs. You also have issues of power and struggles over different ideologies. So these are things that can lend themselves to interesting writing, but you have to make it interesting. And so one of my goals is to help you understand how to do that. And there are a number of sort of tools in the writers and reporters tool chest that you can use to help. And that's the purpose of this lecture, and also the discussion question that you're going to be doing along with it. And it's also the purpose really of that reading that I've had you look at by Robert Kunzig, talking about basically sort of the pleasures of writing about science, the pleasures of discovering things. And I really appreciate that about Kunzig's writing. Not only is he expressing his appreciation for that kind of writing, but his writing itself is really a pleasure to read. And so he's modeling for you how to do that. So I've been talking for a while. Let me take you down to some detailed lessons about how to do this in your own writing. We're going to go through a couple of basic tools that you can use, and then I'm going to show you some examples of those so that you can sort of picture how that might get applied to your own writing. First, let's look at some examples of how to make the unfamiliar familiar, and hopefully that will help you understand how to apply this in your own writing. One of the most common ways that you do this is that you compare measurements to common things. Often when you're writing about scientific matters or policy or really anything that's complicated with lots of details, you're going to wind up with statistics that might seem strange or that won't really register with your readers. So, or viewers if it's a video. So some of those examples would be distance, volume, size, shape, number, time. Any of these things might seem unfamiliar to your readers. So let's look at a couple of examples of how you deal with that. So here's an example of size. Just a heads up, almost all of these examples are going to be from my own writing, not because my own writing is particularly special, but because it's the writing that I know really well, so I can I can find examples for you easily. So here's a sentence here that I'll just read to you, or a paragraph. It says, the landscape is vast. It's also just a sliver of the habitat that produces Bristol Bay's salmon runs. 9 large rivers drain watersheds covering an area the size of Virginia, virtually devoid of humans, save for the occasional fishing lodge and native village. So when I started out with this story, I was told the square kilometers that was covered by the drainage, but I knew that telling readers the square kilometer just wouldn't really mean much of anything to them. But if I could compare it to something like the size of a state, that would be useful. And so I described it as, the size of Virginia. And so you can imagine that people can picture that more clearly. And the same thing goes for all manner of different sizes and shapes and other things. If you can compare a statistic or measurement that is hard to picture to something that's very easy to picture, whether it's like something that's the size of a soccer ball, or that's the size of the state of Virginia, or the size of a car, those kinds of things can really help. I'll show you another example. This is an example from another story where I actually have a lot of comparisons kind of packed into one paragraph. When I started out with this paragraph, it was filled with a lot of technical jargon. And when I was done with it, I realized that most readers wouldn't really understand what it meant, so they'd just breeze on by. It wouldn't really matter to them. So I had to do some calculations to figure out how to make it seem more common. So let's just take a look at this. Cesium-137 and strontium-90 are the hot potatoes of the nuclear waste world, packing a powerful radioactive punch in a relatively short half-life of 30 years. At Hanford, there's barely enough to fill the back of a pickup truck. Yet it contains more than 100 million curies of radiation, roughly 1/10 the radiation in the core of a large nuclear reactor, and it produces enough heat to power more than 200 homes. So I've got a lot of things that I'm trying to make common here. I'm trying to make the unfamiliar familiar. So for starters, how much of that radioactive material is there? It's enough to fill the back of a pickup truck. I had to actually do a fair amount of calculations because I had to calculate exactly how much waste is contained in all these little tubes, and then I had to go figure out how big the back of a pickup truck was. So these kinds of comparisons can take a little work for you as a reporter, but the reward is that your writing is much cleaner and clearer, and readers will actually remember it. Likewise, for 100 million curies of radiation, right? That sounds like a lot, but as a reader, do you really know how much it is? Probably not. But if you say it's 1/10 the radiation in a large nuclear reactor, then you get a sense of, right, that is a ton. So it helps really bring it home for the reader. It helps give them something that they're familiar with. Likewise, it produces enough heat to power more than 200 homes. I think the heat was originally measured in some unit that people typically don't use, and so it wouldn't have meant anything. So I had to find something familiar, something common. Sometimes when you're not dealing with statistics, but you're dealing with objects or processes, you have to compare those to common things also. You have to make those familiar. You might use metaphors or similes, likening an unfamiliar thing to a familiar thing. You can see in this paragraph that I have, I'll just read it. Paris and her research partner, chemical engineer Zachary Amann, used one of the world's toughest blenders to try to solve the puzzle. Now, they did not call this thing a blender. They called it something else. I don't even remember what, but it was a very fancy name. But essentially, it was a blender. And so I know that readers are going to have an idea of what a blender is, and so I just call it a blender. Let's go a little further. The mixer housed at Amann's lab at the University of Western Australia, Crawley, is the size of a champagne glass made of industrial sapphire strong enough to contain pressures 100 times greater than that found at Earth's surface. Okay, so again, I'm comparing it to a champagne glass just to give people a sense of what the size of it really is. And then to describe just how strong this industrial sapphire is, pressure 20 times greater than what you find at Earth's surface. Now, do readers know exactly what that feels like? No, but they can grasp that it's a lot. All right, so another thing is to use fun, simple language. I think people too often forget that the language that seems familiar to them is actually jargon or is hard to read. And so think about it like this. How would you explain this thing that you're writing about to a friend? A friend who, is not scientifically illiterate, but is not an expert in the thing that you're writing about, right? If you were just talking to them over coffee and trying to describe something, what kind of language would you use? So I want to just play you an example here on the radio. This is from Radiolab, which is they do a terrific job in that podcast and radio show in explaining scientific jargon in really clear and fun ways. So let's just listen to an example of how they do that.
So here's what she did. She went into the forest, got some trees.
Douglas fir, birch, and cedar. And then I would cover them in plastic bags. So I'd seal the tree in a plastic bag, and then I would inject gas, so tagged with an isotope, which is radioactive.
So these trees were basically covered with bags that were then filled with radioactive gas.
Yeah.
Which the trees
would just suck up through photosynthesis.
So now they had the radioactive particles inside their trunks and their branches.
We had a Geiger counter out there. As soon as we labeled them, we used the Geiger counter and ran it up and down the trees, and we could tell that they were hot. They were boo, 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 right?
And the idea was she wanted to know, once the radioactive particles were in the tree, what happens next? Would they stay in the tree, or would they go down to the roots, and then what happens? And what she discovered is that all these trees that were of totally different species, were sharing their food underground. Like, if you put food into one tree over here, it would end up in another tree maybe 30 feet away over there, and then a third tree over here, and then a fourth tree over there, and a fifth tree over there, 6th, 7th, 8th, 9th, 10th, 11th. All in all, it turns out one tree was connected to 47 other trees all around it. It was like a huge network.
Okay, so needless to say, when you're writing a story for the planet, you don't have the benefit of sound effects, which Radiolab does. But regardless, Robert Krulwich does a really great job of using very simple, straightforward language to explain complicated science. If you read the scientific paper that spells out that research, it would be very technical and hard to understand. But Robert does a terrific job of telling the research in very simple ways. And you can just see, here's an example right here at the very end. He talks about the different species sharing their food underground. Well, that is basically what's happening, but I can bet you that the scientists do not talk about the trees sharing food. So that's just an example of getting that kind of language that's simple and approachable. It really is like you're telling a story to a friend. Now, that piece was pretty long. For your paper, you might not take nearly that much time to explain scientific research. And likewise, if you were explaining how a bill moved through the legislature or any kind of complex policy issue. But you can still use that really simple, straightforward language. Okay, so now here's the flip side. I've been talking about how to make the unfamiliar familiar. Now let's talk a little bit about how to make the familiar strange. And this is something that happens less often in a story, but it's really an important thing to keep in mind, because the natural world and science and policy, they're amazing things. And so you don't want to lose sight of that. Part of what we're trying to do is sort of to amaze our readers, but you want to amaze them in ways that actually connect. So there's just a couple of examples on how to do that. One is that you should look for cool details. If you find a detail when you're reporting and it makes you think, wow, that's cool, you should think about maybe a way to fit that into your story, because your reader is likely to have the same response. So here's an example. I was trying to describe, this is for a story about explorations of underwater volcanoes called seamounts. And I'm just going to read it to you right now. Submerged 1 kilometer beneath the ship in permanent darkness and crushing pressure was a dead volcano, the tropic seamount. One treasure bloomed on its flanks, an otherworldly multicolored forest. Curled pale sponges that looked like potato chips the size of dinner plates grew there, as did spindly white corals festooned with squid egg sacs. Right, so I'm looking for little memorable details that will make people go, wow, that's cool, right? So like, sponges that look like potato chips the size of dinner plates. And by the way, I did actually have to look up how big those sponges grew and compare them to a dinner plate to make sure that I was being accurate. But so that's one way to capture sort of the strangeness of the world, right? Is to find these little cool details. And then another thing related to that is what I would call shocking statistics. That is statistics that just kind of blow your mind, right? And you see this used in news stories and magazine stories and videos and things like that. And you often run into it when they're talking about the size of the universe and how many galaxies are in it, right? These statistics just kind of take your breath away. So I don't have statistics that good, but this actually carries on to the same story that you saw in the last slide. So I'll just keep on with it. Much of that life clung to rock coated with a black bumpy skin as bland as asphalt. That crust, about 12 centimeters thick, is the other treasure, rich in the rare minerals that help drive the modern economy. On the tropic seamount alone, it might hold enough cobalt to power 277 million electric cars, and enough tellurium to build solar panels generating more than half of the United Kingdom's electricity. So those are huge numbers, right? 277 million electric cars from one seamount. So it's those kinds of things that can really catch a reader's imagination and attention. And I would just point out that I also used a metaphor at the very top, or a simile actually, to describe this coating, referring to it as being as bland as asphalt. So that's another way, again, to sort of evoke the reader's imagination and to connect them with complicated issues, but in a way that feels real and straightforward to them. All right, I hope these examples are helpful, and I'd love to see you guys integrate some of these tools into your own writing. Okay, I hope that helps you understand some of the sort of tools that are at your disposal as you're working to make your writing about science and policy and other complex things really engaging. There's one important tool that I forgot to mention during that PowerPoint slide, and so I just want to call it out now, and that tool is verbs. Verbs are really some of the most sort of potent parts of a sentence. They're the things that can really drive action. It can really convey to readers what's happening. Or if you use sort of weak verbs, they can kind of kill a sentence. And so think about the verbs that you're going to use. There's some examples from the paragraphs that I've just shared with you. Verbs like clung or bloomed, or even simpler things like sharing, right, to describe how plants move nutrients between from one tree to the next, right? So think about the kind of verbs that you're going to use and look for ways to use verbs that are evocative and engaging and interesting and also understandable to the reader. And the other sort of side of that rule is be very careful with adverbs. Don't use them unless they're really critical or valuable. That's one of the common mistakes that I see, is an overuse of adverbs when really what you need is a stronger verb. So for example, you might describe you might say that someone ran quickly. Right? So quickly is the adverb, but couldn't you just think of a better verb for that, like sprinted? So as you're writing, when you start using adverbs, ask yourself, do I really need that adverb, or do I need a better verb? Okay, I hope these things are helpful. I look forward to seeing some of these lessons showing up in your writing for the discussion question and also for the second draft. Good luck. Take care.